Hello guys, my name is Soumya from Anara Institute of Technology. Today my topic is about machine learning. Contents which we are going to discuss in this session are introduction, models of machine learning, calculating the accuracy of regression and classification models, training data, validating data and testing data. First one, introduction. What is machine learning? Machine learning is a field of study that gives a computer the capability to learn without being explicitly programmed, which means a machine is said to be learned on its own. It is able to take experience and utilize it in such a way that to improve the performance on the same experience in the future. Machine learning is consisting of three types: supervised machine learning, unsupervised machine learning, and reinforcement machine learning. First one, supervised machine learning. Supervised machine learning model takes a labeled input and predict the output based upon the past experiences. If you see in this picture, here we have given some label data with labels to the models, and model is trained with the label data, and when testing data is given, it gives the output as the labels which we have trained before. Supervised machine learning is again classified into two types. There are classification and regression. Here if you see in this picture, classification means it takes a categorical variable in the algorithm in order to drive output. Regression means it uses numerical variables and use it to find exact or approximate value by numerical variables. Classification diagram, if you see in this diagram, we are classifying the mails into spam and non-spam. In a regression diagram, if you see in this example, it is a house price example. Here we have some price based on the features. The most accurate prices were taken and draw the straight line on them, and that straight line is called best fit line, and that is about regression. Unsupervised learning. Unsupervised machine learning model takes unlabeled data as an input and predict the output based depending upon the features and patterns. If you see in this picture, here we have given some unlabeled data to the model, and based on the features and patterns, it classifies them and gives the output. Next, reinforcement machine learning. Reinforcement machine learning is a feedback based model. In this, if the predicted output is not the actual output, then again we need to perform the same action for predicting the output. It predicts the output based upon the states and actions of an agent. If the agent works well corresponding to the action of a state, he will be rewarded, otherwise he will be receiving a penalty. Next, calculating the accuracy of regression. Regression is the relation between two variables. It is used to find the exact value or approximate value. There are different types of calculating the accuracy of regression, which are mean absolute error, MAE, root mean square error, RMSE, mean absolute percentage error, MAPE. Formula for MAE is summation of error by n. RMSE formula is square root of summation of error square by n. MAPE formula is 1 by n, summation I is equals to 1 to n, modulus of A dot V minus P dot V by A dot V into 100. Here we have given example with some weights and actual height and predicted height and some error. And here error is calculated with the difference between predicted height and actual height. Here formula for MAE, mean absolute error, is summation of error by n. Here we are adding all the errors with the n value is number of weights we have taken is 6. So here we are calculating all the, we are adding all the errors here by total number of weights. Here 150 by 6. By calculating MAE, we'll be getting 25. Here RMSE we can formula is square root of summation of error square by n. By calculating all the errors square by n by number of weights, here we'll be getting square root of 4900 by 6. The approximate value of RMSE is 28. Next one, MAPE, mean absolute percentage error. Here the formula is 1 by n, summation of I equal to 1 to n, modulus of A dot V minus P dot V by A dot V into 100. Here n value is 6, and A dot V minus P dot V means actual value minus predicted value by actual value into 100. Here by calculating by using the formula, we'll be getting this answer. So by calculating all the things, we'll be getting 14.85. By comparing all the calculating the accuracy of regression, the most accurate one is MAP, which is mean absolute percentage error. Next one, calculating the accuracy of classification. In the classification, we can find the accuracy of any classification problem by using the confusion matrix. There are different types of calculating the accuracy of classification, which are like accuracy, precision, recall, specificity, and F1 score. First, we'll learn about confusion matrix. So, confusion matrix is consisting of predicted values and actual values. Rows represents the actual values and columns represents the predicted values. Here, we are having true positive, false negative, and true negative. If the predicted value is consisting of 1 and actual value is also 1, then it takes true positive. If the predicted value is 0 and the actual value is also 1, then it takes false positive. If the predicted value is 1 and actual value is 0, then it takes false negative, and predicted value is 0 and actual value is 0, then it takes true negative. Here we have taken some example with actual values and predicted values here. So as I said earlier, if the actual value is output 0 and the predicted output is 0, then it takes true negative. If the actual output is 1 and predicted output is 0, then it takes false negative. And we have calculated these things accordingly. Here total number of true positives are 3, true negatives are 2, and false positives are 2, and false negatives are 1. So these are the formulas for calculating the accuracy of classification problems. Accuracy: true positive plus true negative by true positive plus false positive plus false negative, which is equals to 3 plus 2 by 3 plus 2 plus 2 plus 1, which is equals to 5 by 8, that is equals to 0.65. Precision formula is true positive by true positive plus false positive. By calculating by using the values, we will be getting 0.6. Recall value is formula is true positive by true positive plus false negative, we will be getting 0.75. Specificity: the formula is true negative by true positive plus false positive. The value by calculating the things, it is 0.4. F1 score formula: 2 into recall into precision by recall plus precision. Recall and precision values were taken from the above and will be calculating accordingly, and will be getting the value of 0.67. Next, training, validating, and testing. In the ML model, it is essential to define the available data into 3 parts: training, validating, and testing. Training data. The training data is used to train the ML model. The model is fitted to the training data to learn the relation between the input data and output data. Next one is validating data. Validating data is access the accuracy and generalization ability of the training model. Otherwise, it is used to tune the hyperparameters of the ML model. Hyperparameters are the parameters of the model that are not learned during training, such as learning rate, regularization, strength, or number of hidden layers. Tuning these hyperparameters helps to improve the performance of a model. Next one is testing data. Testing data is used to evaluate the performance of the ML model on unseen data. After training and validation, the final performance of the model is measured on the testing data. This is done to ensure that the model has not overfit to the training data and can generalize well to new data. Testing data should never be used for training or tuning the model. Testing data should not only be used for final evaluation of the model performance. Thank you.